Problem 3 here asks us to refer back to problem 2. Now we had a transition diagram in problem 2, and then we converted it to this transition matrix. And what we want to do is this. We want to find the probability of going from state A to C, right, A to C, but in 3 transitions. And then we'll show how we get our answer. So we want to go from A to C in 3 transitions. Now, the transition diagram here tells us the probability of going from A to C in one transition is 0. And looking at the diagram, there is no way to get from A to C in one transition. But perhaps what we could do is we want 3 transitions. We could go, see if this works. We could go from A to A back to A, that's 1, and then to B, and then to C. Right? So we could go A to B, and then to C. There's 3 transitions. Or we could go, how about A to B, B to B, and then B to C. There's another 3 transitions. In fact, here's another one, I think. How about if we went A to B, B to C, and then C back to C? There's A to C in 3 transitions. But what we can do is we can write our transition matrix to the 3rd power. So what we're going to do is take our transition matrix and raise it to the 3rd power, and that should give it to us. So this is going to be, well, let's write what we have here. This is going to be, here's A, B, and C, and then we need to compute this. So on your calculator, I think you can go into, right, second matrix, and then maybe choose A, and put A in like this. A is going to be, well, what size is it? It's a 3 by 3, and then what we're going to get here is we're just going to put these numbers that we see in here. Oop, that's a mess. Put these numbers in. So we're going to get, right, let's just put these numbers in. So it goes across the rows, right, when we put these in. It's going to go 0.9, enter, 0.2, enter, 0, enter. That drops us down here. 0.1, enter, 0.1, enter, 0.3, enter, drops us down to 3rd column, 1st row. So 0, enter, 0.7, enter, 0.7, enter. It closes automatically, but now remember, when you hit that 0.7, be sure to enter it and then do second quit. Get out of there. If you type anything else, it's going to think you're putting it in here. So do 0.7, second quit. And now go back to second matrix and select A, and we'll cube that. And when I did that, here's what I got. I'll write these numbers. I'm going to write them back up in here. So here's T cubed. I'm getting A to A, 0.767, A to B, 0.114, A to C, 0.119. Now look, that's really all we need here, right? That's what I'm looking for. I want to go from A to C, right? From, where are we? I want to go from A to C in 3 transitions, so I've got it here. It's the 0.119. So I know my answer is going to be 0.119. That's about 12%. So there's a 12% chance we can go from A to C in 3 transitions. But I'll finish this off here. If we're in B, probably going to A in 3 transition is 0.228, back to B in 3 transitions, 0.212, and then from B to C in 3 transitions, 0.560. And then C, if we're currently in C, probably going to A in 3 transitions, I got 0.102, and from C to B in 3, 0.240, and the probability of remaining in C, if we start in C, do 3 transitions and get back to C, I'm getting 0.658. But our problem just asks us, what's the probability of going from A to C, from A to C in 3 transitions? I'll take the transition matrix, raise it to the 3rd power, and that's my answer right there.